Hi, in this video I want to talk about end behavior of polynomial graphs. And in behavior, what we're talking about is what happens on the ends of the graphs. In other words, I'm not really interested in this middle portion of the graph. I'm interested in what happens out at the ends, okay? Out here and out here, which is basically saying, hey, as x gets really big, as x gets infinitely large, what happens to the y-coordinate? And when x gets infinitely large but in the negative direction, so as I go farther left and left and left and left, what happens to the y-coordinate? Okay, so I'm not interested in the middle. That would be called middle behavior. Okay, I'm not interested in that. This is called end behavior of polynomial functions. And so what I've done here is I want to just graph real quick. This is x cubed is what you're seeing, and you'll notice it looks like an S curve. Okay, and in fact what I've done here is I've typed in a bunch of these just to save some time. X to the third, x to the fifth, x to the seventh, x to the ninth. No, ignore the ones at the bottom. Okay, and notice that those are all odd powers, right? X cubed, x to the fifth, x to the seventh, x to the ninth. And if I go and I graph all of them, which I can do by just highlighting the equal sign on here, if I just graph these four, I want you to notice the shape of each of these graphs. There's x cubed, it's already up. There's x to the fifth. Here comes x to the seventh. It's quick. And then x to the ninth, which looks a lot like x to the seventh, right? And notice that they all have basically the same shape. They're all an S curve. Okay, and so we come up with a pattern here, and the pattern is this. If the degree of a function is odd, in other words, we're talking about x cubed, x to the fifth, x to the seventh, so on, okay? X to the 433rd power, that's an odd number. If the degree of this is odd, and really remember that means that even if I have more than one power, that means the highest power of x is odd. And the leading coefficient, that means the very first value in front of the highest power. So in other words, let's go back here, okay? In fact, we can go look at something like this, right? X cubed minus 3x squared plus 2. When I graph this one, that is a third degree equation, third degree polynomial because it's x cubed, and it's a positive x cubed. That means the leading coefficient is positive here, okay? We notice that we have an S curve, and it always does the same things on the end. It always goes down as it goes to the left, and it goes up as it goes to the right. Interesting, okay? Now notice, all I did there, whenever I put in all this junk at the end, x cubed is really the thing that determines what the graph looks like. If you have an odd power, it's going to look like an S curve. The other stuff at the end, all that does is change what happens in the middle. So we get more of this curvature in the middle as opposed to just kind of being a flat S curve, okay? Notice what happens whenever I graph this one. That looks like a pretty complicated equation, right? X to the fifth minus 2x fourth plus 3x squared minus 2x minus 1, okay? That is a fifth degree polynomial because x to the fifth is the highest power. Furthermore, it is a positive x to the fifth. So it's going to look like an S curve. It might just have some more stuff going on in the middle. And when I graph that, look at that. It looks almost exactly the same. Kind of tough to see. Hold on. Let me just delete that one real quick. Whenever this shows up, look at that, an S curve, and it still goes down as we go to the left, and it still goes up as we go to the right. Now, it wouldn't be right if mathematicians didn't have a fancy symbol or something to write all this stuff out. And so what you'll see is a statement that looks like this, and usually it's on one line, it's on two lines to save space here, but basically it says this: the y-coordinate on the left-hand side goes downward. Downward forever, really. It never stops going down. So we say that it goes to negative infinity. That's our way of saying it goes down forever as the x-coordinate goes farther to the left, as x goes to negative infinity. The y-coordinate goes to negative infinity, down forever, as x goes to negative infinity. It goes left forever. And on the other side, we have the y-coordinate goes to positive infinity. It goes up forever and ever and ever, as long as x is going to positive infinity. And that's just a fancy way of saying, listen, on the left side it goes down, and on the right side it goes up. And that happens to be the case for every single odd function, as long as the leading coefficient is positive. So what I want to do real quick, just to finish this off, okay, let's change this. Let's insert some negative signs. What if it's negative x cubed? What if it's negative x to the fifth? What if it's negative x to the fifth minus 2x to the fourth plus 3x squared minus 2x minus 1. So the only thing I've changed is I made the leading coefficient, the thing in front of the highest power of x, I made it negative now, okay? So I have an odd degree and this time I have a negative leading coefficient. And you'll notice all that happens here is everything gets flipped upside down. There's negative x cubed, negative x to the 5th, and here comes that s-curve with a little more stuff going on in the middle. That was that last one, okay? Hard to see, but notice they're all the same, and they all look like this. So all we say then on this is that f of x, the y-coordinate goes upward, that would be positive infinity, as the x-coordinate goes to the left. That would be negative infinity. So notice they're backwards now, right? These were both positive, now they're opposite signs. Over here we say the y-coordinate goes down, that would be negative infinity, as the x-coordinate goes to the right, that would be positive infinity. And every single odd function is the same. They go opposite directions. You need to decide then, if it's a positive leading coefficient, it goes like this. If it's a negative leading coefficient, it goes like this. That's what happens on the end. The junk in the middle is determined by the extra stuff that we add at the end of the equation.